Intermediate Algebra. Congratulations, you've made it to Chapter 2. And we're going to start out, as you might have guessed, with Section 1. However, be aware that Chapter 2 is about linear equations in two variables and functions. That is the title of our second chapter. And let's get into Chapter 1. The first thing that we need to make sure that we're aware of is that we're going to be operating on the Cartesian coordinate plane, which is chopped up into four different quadrants by the x and y axis. The quadrants are labeled in counterclockwise order, starting in the top right, 1, 2, 3, and 4. And the point where our the point where our axes meet, the x and y axes meet at the origin. And we're going to be plotting some ordered pairs on the coordinate plane first, just to make sure that everyone's on the same page. And if the first point that I'm going to plot is 2, 0, I start at the origin, and then I move 2 units in the positive x direction. So that's our 2. Moving 2 units in the positive x direction puts us here, and we're moving 0 units in the y direction. So that's point A. Point B moves us 4 units in the negative x direction, and then this y coordinate here says that we're moving 1 unit in the positive y direction, which moves us up to this point right here. The solution to, or a solution, I should say, to a linear equation is expressed as an ordered pair, x, y. And in this first example, we can determine if 0, 4 is a solution to this given equation by simply taking our x and y values, plugging them into the equation, and seeing if it satisfies the equation or makes it true. Let's see if it works. Plugging in a 0 for x gives us 2 times 0 minus 3 times our y value of 4, and supposedly that's equal to negative 12. 2 times 0 is 0, minus 3 times 4 is 12. Is 0 minus 4 equal to, is 0 minus 12 equal to negative 12? It sure is. So we would say that 0, 4 is a solution to this equation. In order to graph a linear equation, it would be sufficient to find 2 points that are going to be on that line and then draw a line through those 2 points, but it's not a bad idea to find a third point or a third solution just to use it as a reference and sort of double check the other 2 points that we were plotting. And in order to generate an ordered pair that is a solution to this equation, you could take an x value and plug it in and calculate the corresponding y value, or you could take a y value and plug it in and generate the corresponding x value. Let's start with an x value of 0. 2 times 0 minus 3 times, we don't know what y is yet, is equal to negative 6. 0 minus, this term turns out to be 0, so we only have a negative 3y remaining on the left-hand side, and a negative 6 on the right-hand side, and then we'll divide both sides by negative 3 in order to isolate our y value. The negative 3's cancel on the left-hand side, and negative 6 divided by negative 3 makes positive 2. So we'll take that positive 2 and put it in here as our y value. And then we can go through similar motions, except the next time we're going to plug in a y value. So we start with our same equation, except this time it's 2 times an unknown x value minus 3 times this y value of negative 2 that was chosen for us is equal to negative 6. Negative 3 times negative 2 makes positive 6. Right-hand side of our equation is still equal to negative 6. And now we need to solve for x. I'm going to solve for x by subtracting 6 from both sides so that this 6 goes away. And now on the left-hand side we have 2x, and on the right-hand side, negative 6 minus 6 makes negative 12. In order to isolate the x on the left-hand side, we will divide both sides by positive 2, leaving the x all alone, and negative 12 divided by 2 equals negative 6 again. That's a lot of negative 6's, weird. And that x value is going to go right over here. And then you could go through the motions and calculate the corresponding y value for an x value of 4. I'm not going to do that. I trust you to do it. I also trust that I know how to do arithmetic, although sometimes my arithmetic abilities are questionable. But I'm going to go for it on this one. And I'm going to plot these 2 points, 0, 2, and negative 6, negative 2. Starting at the origin, moving horizontally 0, and then moving 2 units in the positive y direction, puts me at a point right here on the y-axis, and then moving from the origin 6 units to the left and 2 units in the negative y direction puts me at this point right here. So there are the 2 points that we plotted. And then if you're graphing this line in some kind of online software, then simply by clicking on these 2 points should snap the line for you. I, however, have to manually draw my line. Pretty close. It'll be nice if you're using online software. That'll be even more accurate. That one looks like it's riding a little low. If that line had been a little bit higher and been a little bit more accurate, the next x-coordinate of 4 probably would have yielded maybe a y value of 5. But again, my line was a little low. But that's my guess. Would have passed through 4, 5. The next equation that we're given is in y equals mx plus b form. And because the coefficient on x is 1/4, as you choose x values to plug into your equation, in order to help you generate corresponding y values, it's recommended that you choose some convenient x values. And since the x values that you plug in are going to be multiplied by 1/4, in other words, divided by 4, it's a good idea to choose x values that are multiples of 4. So let's look at the 0 first. I'm just going to do these in my head. 0 plugged in for x, 1/4 times 0 is 0, plus 1 is 1. And then let's plug in an x value of 4. 4 times 1/4 is 1, plus 1 makes 2. 8 times 1/4 is 2, plus 1 is 3. And if we plugged in an x value of 12, I bet you can guess what the y value would be. And then we can come over onto the graph and plot these points over 0, up 1, over 4, up 2, over 8, up 3. Those look like they're going to be all on the same line. And they're supposed to be. That was more accurate. Again, not perfect, but closer. So that is our line. On that line are a whole bunch of points, infinitely many points. And if you pick any point on this line, like this point right here, that point is going to have coordinates. This point has coordinates -4, 0. And I would be willing to bet that if you take an x value of -4 and you plug it into our equation, -4 times 1/4 makes -1. -1 plus 1 makes a y value of 0, which is exactly what we have right here. Nice. What that means is that a line, a graphed line, is actually the graph or the plotting of all of the solutions to a particular equation. Interesting. A little bit interesting. Determining x and y intercepts. You can find an x-intercept by plugging in a y value of 0. You can find a y-intercept by plugging in an x value of 0. Why is that? Let's borrow. Can I get this to slide down? There we go. An x-intercept, remember, is the point where a graph crosses the x-axis. This point right here is an x-intercept. Whether you have that point as your x-intercept, or this point, or this point, or this point, or this one. Every one of those red dots that I just put on my graph have something in common. They all have, and this one, hold still. This one does also. All of those points have something in common. They all have a y value of 0, which is why if you're trying to find an x-intercept, which will be a point on the x-axis, you know that the y-coordinate's going to be 0, which is why these instructions are telling us that in order to find an x-intercept, you should plug in a y value of 0. So, in this problem, let's find the x and y intercepts. For the x-intercept, we're going to let y equal 0. Let's plug in that y value of 0. 4x minus 0 equals 8. Divide both sides by 4, and we get an x value of 2. So we will be able to plot the point 2, 0. Let's go ahead and put that on our graph right away. Over 2, up 0. There it is. Now, in order to find the y-intercept, we're going to let x equal 0. In our equation, that means we're doing 4 times our new x value of 0, minus we don't know what y is yet, is equal to 8. The 4 times 0 is obviously 0, so the left-hand side of our equation now says negative y, still equal to the 8 on the right-hand side. And if we multiply or divide both sides by negative 1, we find that our y value is negative 8. So we get to plot the point. Remember that we started with an x value of 0, which yielded a y value of negative 8. So that's the point we're going to plot. Starting at the origin, moving 0 units horizontally, moving 8 units in the negative y direction, puts us pretty far down on the y-axis, right here, and then you can draw your line through those 2 points. That's my best one yet. So far, all the lines we've looked at have been diagonal lines. Is it possible to write an equation for a horizontal or a vertical line? Absolutely. The equations for those are kind of unique looking, however. If you imagine a vertical line maybe passing through the number 2 on the x-axis, each and every one of these points has something in common. These points all have an x-coordinate of 2, which is why the equation for this vertical line is x equals 2. And we're being told in this orangish colored box that, generally speaking, the equation for a vertical line is going to take on the form x equals some number. Similarly, a horizontal line may be passing through negative 3. Every one of the points on this blue line has something in common. All of those points have a y-coordinate of negative 3. And so the equation for that horizontal line would be y equals negative 3. More generally speaking, back to our orange box, a horizontal line, or the equation for a horizontal line, is going to take on this form, y equals some number. They're writing it as y equals k. So here we're being asked to graph y equal, oh, that's interesting. I didn't actually see this. Maybe my eye saw it and I didn't even realize. So y equals -3. Let's go ahead and put that on our graph. Every point on that line has a y value of -3, and x equals +4. Is a line where every point on it has an x-coordinate of +4. Horizontal and vertical lines. And amazingly, that is the end of the first section in Chapter 2. Tackle some homework about those lines, and remember that if you're answering these problems online, which I know that my students are, make sure that if a problem asks you to graph a line by plotting the x and y intercepts, in order to get the question correct, the 2 points that you click on in order to snap your line onto the graph, those 2 points that you click on must be the x and y intercepts. Could you conceivably click on this point at 0, -8 and this point at 1, -4 and get the same line? Absolutely. Whatever software you're using online, however, is probably going to tell you that you got the wrong answer because you didn't get the correct line by clicking on the correct 2 points. It's trying to ascertain whether or not you know how to find and then click on the x and y intercepts. So make sure that you do that. You should have no problem, and I will see you in 2.2.